guys, and welcome to this next video in our Properties of Geometric Figures series. This one is all about polygons. Now, polygons are just any straight-sided shape, and that is going to be our definition today. So our definition of polygons is many-sided shapes. So poly meaning the many. Alright, so it is a shape, which is what our gon part really says. And it has straight sides, and it can have any number of straight sides from 3 up, okay? But that's essentially what a polygon is, a shape with straight sides. The names of the polygons are based around how many sides they have. So if a polygon has 3 sides, it's a triangle. 4, it's a quadrilateral. If it's a 5-sided shape, it's a pentagon, and so on and so forth. So each polygon has a special name based around the number of sides. Now, when we're working with polygons, different straight-sided shapes, we do need to sometimes work out internal angles. The internal angle sum of a polygon is written using a formula. And the formula for finding the internal sum of a polygon is S for sum equals n for the number of sides minus 2 times 180 sides in our polygon, subtract 2 and multiply that all by 180. Now we do have an example here for us to quickly look at. We have a 5-sided shape. We go 5 minus 2 times 180. So that's really 3 times 180. And 3 lots of 180 is 540. So a 5-sided shape has an internal angle sum of 540 degrees. Now there are some regular polygons and irregular polygons. The difference being that a regular polygon, a regular polygon will have equal sides and equal angles. Alright, so these have equal sides and equal angles. So all of the angles inside a regular polygon are equal. All of the sides of a regular polygon are equal. We have 3 examples here. We have our square, which we learnt from the quadrilaterals video that it has all equal sides and equal angles. Now we have a regular pentagon, and we have a regular hexagon. And you can see that all of those angles, so all of these little angles are all the same size, and that goes for the other shapes as well. Now, not only do these shapes have internal angles, these shapes also have external angles. So let's have a quick look at those. So here's our example of external angles. If I extend the line from my triangle here past the vertex, I get an external angle. So the external angle is that one outside. Now we have learned about external angles in triangles before, but one of the things that we note with this particular one is not that so much that these guys will be equal. If it is a regular polygon, they should be. But external angles actually need to sum to 360. Okay, and so that's what we're going to pop on our page now. In every polygon, the exterior angles must sum to 360 degrees. So for our example, A plus B plus C must equal 360 degrees. Okay, so that is what we're going to be looking at with polygons today. Let's have a quick look at some examples before we finish up. Okay, for this polygon here, our top polygon, we want to find the angle sum, and then we want to find the value of x. So we already know one part of it. We know that the angle sum is based off this formula, s equals n minus 2 times 180. And now we substitute in what we know for that. So how many sides do we have? 1, 2, 3, 4, 5, 6 sides. So we have a 6-sided shape. So it's 6 minus 2 times 180. So 4 times 180. And 4 lots of 180 is 720 degrees. Okay. So 720 degrees is our angle sum. So all 6 of those angles needs to add to 720. That's going to help us work out x. Now one thing to remember in here, that angle is 90 degrees. It's our right angle, so it's 90 degrees. What we can do here is we can very quickly say that 720 degrees equals all 6 of those angles added together. So x plus 140 plus 130 plus 90 plus 150 plus 100. But the easiest way to do this is to go with the x. So x equals 720 minus those other numbers. So let's pop that in our list. And then once we calculate that all up, we're going to get 110 degrees, 110 degrees. Let's see how that works within the calculator. So here's our calculator. Let's turn it on. And we're going to go 720 minus, now open up my bracket. It's going to be 140 plus 130 plus the 90 plus the 150 plus the 100. I'm going to close off my bracket. Hit equals. That gives me the 110. Perfect, we've done it correctly. Let's crack on to this second example now. We've got a few things to find here. Alright. First of all, we want to find the perimeter of the pentagon. If one side of said pentagon is 7, if one side of the pentagon is 7, then all 5 sides together will be 7 times 5 or 5 times 7. It doesn't really matter which way around we go. It's going to give us 35 centimeters. So that's the first part of our problem. Next, we want to find the internal angle sum. So we've knowing how to do that, we're going to use that formula again. And since we did this in the example previously, we should already know what this is going to come out to. Because it is a pentagon, it's a 5-sided shape. So we are at 540 degrees. 540 degrees. There's our internal angle sum. Define the size of each interior angle. So we can see there it's a regular polygon. Okay, this one is a regular polygon. So that means all the angles are the same, just like all the sides. So x is going to equal our interior sum, which is 540, divided by the number of vertices, which is 5. And for that one, we're going to get 108 degrees. $108. So each of those angles is 108 degrees. X equals 108. Our last bit there is we want to find the sides of Y, which is the exterior angles. So we know that all the exterior angles add to 360. So Y is going to be 360 divided by the number of exterior angles, which again is 5. And 360 divided by 5, well, that's 72. So that one's 72 degrees. That's it. That's all there is to polygons for our purposes in this video and the exercise. Hopefully this video has given you some help. Thank you for watching, and I'll see you in the next one.